Right now, 21 billion kilometers from where you are sitting, a machine older than most people alive is whispering back to Earth. Its voice is so faint that the signal arriving at our antennas carries less power than a dying watch battery. It takes almost 20 hours for a single message to reach us. And yet, inside those fragile transmissions, scientists have just found something that has quietly rewritten what we thought we knew. Not once, but twice. A discovery hidden at the edge of the solar system, and another one buried in data recorded 40 years ago. This is the story nobody expected Voyager 2 to still be telling. Every few days, deep inside NASA's Deep Space Network, a massive dish antenna turns toward a specific point in the southern sky and listens. What it hears is almost nothing, a trickle of data crawling across the void at a rate slower than the earliest internet modems. By late 2023, Voyager 2 was transmitting scientific data at roughly 160 bits per second. To put that in perspective, the message you send on your phone in a fraction of a second would take the spacecraft several minutes to deliver. And yet engineers treat every one of those bits like treasure, because each one is coming from a place no other functioning machine in human history has ever been. But here's what makes this story strange. The spacecraft sending those signals was never supposed to survive this long, not even close. Voyager 2 launched in 1977 with an original assignment of about 5 years, a mission to study the outer planets, and it has now far surpassed that, becoming part of NASA's longest-running mission. Think about what that means. The engineers who built it used technology from the era of punch cards and slide rules. Many of them have retired. Some have passed away. And their machine is still out there, still working, still discovering. That alone would be remarkable. But it's not the discovery we're here to talk about. To understand what Voyager 2 has actually found, you first need to understand where it is, because the location itself is the beginning of the mystery. As of February 2026, Voyager 2 is over 143 astronomical units from Earth, more than 21 billion kilometers, or roughly 3 billion miles away. That is so far that the concept of distance almost stops making sense. A radio signal traveling at the speed of light, the fastest anything can move in this universe, needs about 19 and a half hours just to make the one-way trip between Earth and the spacecraft. If mission controllers send a command in the morning, the answer doesn't come back until nearly 2 days later. Every conversation with Voyager 2 is a conversation across time itself. And this is where the story turns. Because in November 2018, something happened out there that scientists had been waiting decades to witness. On November 5th, 2018, at a distance of 119, 7 astronomical units from the Sun, Voyager 2 crossed out of the Sun's protective bubble and entered the interstellar medium, the space between the stars. Only one other object built by human hands had ever done this before. Its twin, Voyager 1, 6 years earlier. But here's the part most people never heard. Voyager 2's crossing wasn't just a repeat of its twin's journey. It was, in a scientific sense, far more important. And the reason why changes everything. When Voyager 1 crossed this boundary in 2012, it was partially blind. Its plasma science instrument, the device designed to directly measure the charged gas flowing through space, had stopped working all the way back in 1980. So when Voyager 1 exited the Sun's bubble, scientists had to infer what was happening from indirect clues. It was like hearing a door slam in another room and guessing what happened. Voyager 2 was different. Its plasma instrument was still alive, which means that when it crossed the boundary, it became the first spacecraft in history to directly sample the electrically charged plasma that fills both the outermost edge of our solar system and interstellar space itself. For the first time, humanity didn't guess. Humanity measured. Now let's talk about what that boundary actually is, because this is where the discoveries begin stacking up. Our sun is not a calm, gentle light in the sky. It is a raging nuclear furnace tearing through the galaxy at hundreds of thousands of kilometers per hour, constantly throwing off a wind of electrically charged particles that rushes outward in every direction, carrying the sun's magnetic field with it. This solar wind inflates a colossal bubble around our entire solar system called the heliosphere. And like oil refusing to mix with water, the sun's wind and the interstellar medium push against each other without blending. Everything you have ever known, every planet, every moon, every human being who has ever lived, exists inside this bubble. And this bubble is not just a curiosity, it is a shield. The heliosphere protects everything inside it, including the fragile DNA in your own cells, from most of the galaxy's highest energy radiation. Read that again. The sun doesn't just give us light and warmth. It wraps our entire solar system in an invisible force field that blocks cosmic radiation capable of shredding the building blocks of life. Without it, the story of life on Earth might look very different. And until Voyager 2 crossed the edge of that shield with working instruments, nobody truly knew what its outer wall looked like. What scientists expected was a gradual fade, the sun's influence slowly weakening, blending softly into the galaxy like a streetlight dimming into fog. What Voyager 2 found was the opposite. Instead of fading out gradually, the boundary turned out to be remarkably sharp and distinct. One moment, the spacecraft was swimming in the sun's wind. The next, it had punched through into something else entirely. It was not a fog bank. It was a wall. And on the other side of that wall, the readings started coming back strange. The instruments confirmed that the plasma in local interstellar space is significantly denser than the plasma inside the heliosphere. And Voyager 2's temperature measurements confirmed that the plasma just outside the bubble is colder than the plasma inside it. Denser, colder. A completely different ocean of matter pressing in on our solar system from every direction. And the shape of our bubble, pushed and squeezed by that outside pressure, turned out to be stranger than the textbook drawings. Data from the two Voyagers suggests the heliosphere is likely shaped something like a blunt bullet. Not a perfect sphere, but a form sculpted by our star's violent motion through the galaxy. But here's where it gets genuinely puzzling, the part that scientists still cannot fully explain. When Voyager 1 crossed the boundary in 2012, its magnetometer recorded something odd. The magnetic field outside the heliosphere appeared to line up with the magnetic field inside it. That made no sense. The interstellar magnetic field belongs to the galaxy. The heliosphere's field belongs to the sun. There was no obvious reason they should match, and scientists largely dismissed it as coincidence, a fluke of one spacecraft crossing at one location. Then Voyager 2 crossed, billions of kilometers away from where its twin had exited, in a completely different region of the bubble's surface. And its magnetometer confirmed the same surprising result. The magnetic field just beyond the boundary is parallel to the field inside, indicating the two fields genuinely align. Two spacecraft, two different exits. One impossible coincidence that is no longer a coincidence. Something out there is organizing the magnetic architecture at the edge of our solar system, and we do not yet know what. Think about what that means. The most fundamental structure separating us from the rest of the galaxy, the wall of our cosmic home, behaves in a way our best models did not predict. And Voyager 2 didn't just find one anomaly at that wall, it found evidence that the wall itself is porous, leaking, alive with activity. Particles from inside the bubble appear to slip outward across the boundary while galactic material presses inward, a turbulent frontier where two winds collide and mix. In the words of the mission's legendary project scientist Ed Stone, who spent decades trying to understand the nature of that boundary. This isn't a clean line on a map. It's a battlefield between our star and the galaxy. And we have exactly two aging scouts reporting from it. Now, you might assume that after crossing into interstellar space, Voyager 2's biggest discoveries were behind it. That's what almost everyone assumed. And that assumption just collapsed. Because the newest revelation from this mission didn't come from where the spacecraft is now. It came from where it was 40 years ago. This is the twist nobody saw coming. In January 1986, Voyager 2 did something no spacecraft had ever done, and no spacecraft has done since. It became the first human-made object to fly past Uranus. In a matter of hours, it transformed a pale blue dot in telescopes into a real world, discovering nearly a dozen unknown moons, revealing a magnetic field bizarrely misaligned with the planet's rotation, and mapping a helix-shaped magnetic tail stretching millions of kilometers into space. But hidden inside that flyby data was a problem. A reading so extreme that it refused to make sense for nearly 4 decades. Voyager 2's instruments recorded radiation levels around Uranus so intense they baffled scientists for almost 40 years. The radiation belts were far more powerful than any model said they should be. The numbers simply shouldn't have existed. For decades, that mystery sat in the archives like an unsolved crime file. Then, in February 2026, just months ago, researchers finally cracked it. Scientists at the Southwest Research Institute announced new research suggesting that Voyager 2 happened to arrive at Uranus during a rare solar wind event, a cosmic storm that flooded the planet's radiation belts with extra energy, similar to storms observed near Earth that dramatically boost radiation levels. In other words, Voyager 2 didn't photograph Uranus on an ordinary day. It caught the planet in the middle of a cosmic perfect storm, a moment of violence that distorted our entire understanding of that world for 2 generations. And the evidence was hiding in plain sight the whole time. The flyby data shows Uranus was generating intense high-frequency waves during the encounter, the strongest such waves detected during the entire Voyager 2 mission. At the time, scientists believed those waves would drain energy away from the radiation belts, but research in the decades since has revealed that, under the right conditions, those same waves can do the exact opposite, accelerating electrons and injecting even more energy into a planet's radiation belts. The clue was always there. Science simply had to grow for 40 years before it could read it. As the study's lead author put it, science has come a long way since the flyby, and comparing the old Voyager data with decades of Earth observations finally unlocked the answer. Stop and consider what this actually means. It means our only close-up portrait of an entire planet, Everything in the textbooks about Uranus's radiation environment was taken during a freak event. The discovery reshapes how scientists think about Uranus and strengthens the argument for why the planet deserves another visit. One spacecraft, one flyby, one storm, and 40 years of planetary science built on a snapshot of chaos. It makes you wonder, what else in the Voyager archives is waiting to be reinterpreted? What other facts about the outer solar system are actually artifacts of a single strange moment in 1986 or 1989? The mission keeps making discoveries not only through its instruments, but through its ghost, the data it left behind. But while scientists celebrate these revelations, there is a shadow hanging over all of it, because the machine responsible for every one of these discoveries is dying. Not suddenly, not dramatically, slowly, watt by watt, in the cold silence beyond the planets. And the fight to keep it alive has become one of the most extraordinary engineering battles ever waged. Voyager 2 has no solar panels. Sunlight out there is far too weak to matter. Instead, it runs on 3 radioisotope thermoelectric generators, each containing spheres of plutonium oxide, whose radioactive decay produces heat that gets converted into electricity. At launch, they supplied about 470 watts of power. That's less than a microwave oven. And that number has been falling every single year since 1977 as the plutonium inside steadily decays. Each spacecraft loses roughly 4 watts of power per year, a slow-motion countdown that no engineer on Earth can stop. You cannot refuel a reactor that is 21 billion kilometers away. You can only ration what remains, and the rationing has become brutal. In April 2023, engineers made a desperate move. They began drawing on a small reservoir of backup power, originally reserved for an onboard safety mechanism, gambling the spacecraft's protective margin to keep its science instruments alive. Think about the decision behind that. They deliberately switched off a safety net on a 46-year-old machine in interstellar space because the data was worth the risk. As the mission's project scientist Linda Spilker explained, the science the Voyagers return becomes more valuable the farther from the sun they travel, so the team is committed to keeping as many instruments running as long as possible. But the mathematics of decay is merciless. In October 2024, NASA announced it had turned off Voyager 2's plasma science instrument, the very instrument that made history at the interstellar crossing, silenced to preserve power for the others. In March 2025, engineers shut down the spacecraft's low-energy charged particle instrument, a device that had been measuring ions, electrons, and cosmic rays from across the solar system and the galaxy. And here's a detail that captures the absurd endurance of this machine. That instrument contained a rotating motor designed and tested to survive 500,000 steps and last 4 years. It performed nearly 8 million steps across more than 4 decades. Hardware built for the disco era has outlived its own specifications by a factor of 16. The shutdowns continue. Voyager 2's cosmic ray subsystem, the instrument that helped confirm the interstellar crossing itself, has been scheduled for shutdown in 2026, leaving the spacecraft to soldier on with its magnetic field and plasma wave instruments. Each spacecraft is dropping to fewer and fewer active instruments, with engineers hoping that Voyager 1 and Voyager 2 can each carry a single operational instrument into the 2030s. One instrument. That's the endgame. A lone sensor, whispering measurements from the space between stars, while everything else aboard goes dark to feed it. NASA's own outlook as 2026 began was sobering. The spacecraft are operating in what amounts to survival mode, with their nuclear power sources estimated to potentially give out this year, though the agency hopes to stretch their lives even longer. Every downlink could be the last one. As Spilker put it, every minute of every day, the Voyagers explore a region where no spacecraft has gone before, which also means every day could be their last. But that same day could bring another interstellar revelation. So the team is pulling out all the stops. That is the tightrope this mission walks. Each morning, Mission Control doesn't know whether they'll receive a discovery or silence. And when the silence eventually comes, when the final watt fades, something strange happens to the story. Because Voyager 2 doesn't stop. It can't stop. Once the probes die, they will simply continue along their trajectories for billions of years to come. No engine needed, no power required. Just momentum, carrying a dead machine through the galaxy long after the sun itself has changed beyond recognition. And bolted to its side is the famous golden record, sounds, music, greetings, and images of Earth, curated as a message for anyone or anything that might one day find it. When Voyager 2 goes silent, it transforms from a spacecraft into an artifact, a message in a bottle thrown into an ocean with no visible shore. Here's what makes the timing of all this so painful. Just as our only interstellar scouts begin shutting down, the questions they raised are multiplying. The strange magnetic alignment at the boundary remains unexplained. The true shape of our protective bubble is still debated. And scientists know that what the Voyagers sampled is only 2 pinpricks on a vast frontier. That's why NASA has launched IMAP, a probe stationed about 1,000,000 miles from Earth that captures energetic neutral atoms, interstellar dust grains from dead stars, and particles bouncing back from the edge of the solar system, all to build a clearer map of our heliosphere and a sharper picture of what lies beyond it. And NASA has been weighing expensive, complex proposals for a new long-term interstellar probe, a true successor, so the Voyager's legacy doesn't end with a slow fizzle. But even if such a mission launched tomorrow, it would take decades to reach where Voyager 2 already is. Whatever happens, there will be a gap, years, maybe generations, when humanity has no living eyes beyond the bubble. Meanwhile, the milestones keep coming, as if the mission refuses to fade quietly. On November 18th, 2026, Voyager 1 will become the first human-made object ever to reach the distance of one full light day from Earth. Over 16 billion miles, the distance light itself travels in 24 hours. Its twin, Voyager 2, follows on its own southern path, the only machine ever to have visited Uranus and Neptune, and one of only two ever to operate beyond the sun's bubble. As of early 2026, both of these small 720-kilogram spacecraft remain operational and communicating from interstellar space 48 years into their journey. Two machines, each lighter than a small car, carrying the entire species' presence in the galaxy. So let's return to where we started, that faint whisper arriving at the Deep Space Network, 20 hours old by the time we hear it. What has Voyager 2 really discovered? Not just a boundary, not just cold, dense plasma or an inexplicable magnetic alignment, not just a 40-year-old storm at Uranus finally understood. Its biggest discovery might be something harder to put in a scientific paper. Proof that the edge of our solar system is not the calm, empty fade-out we imagined. It is sharp, structured, turbulent, and stranger than our models, and proof that data never truly dies. A measurement taken in 1986 just rewrote a planet's story in 2026. What will the measurements taken this year reveal in 2066? And that leaves us with the questions that should keep you up at night. If the magnetic fields inside and outside our bubble align for reasons we cannot explain, what does that say about how little we understand the space our solar system swims through? If our only portrait of Uranus was taken during a freak cosmic storm, how many other facts about our solar system are illusions of timing? And if Voyager 2's power fades before its successor is even built, how long will humanity remain deaf and blind beyond the edge of the sun's shield? Decades or generations? Somewhere out there, right now, a machine from 1977 is still listening to the space between the stars, running on its last watts, one transmission at a time. And the most unsettling thought of all is this: the day it finally goes silent, we won't know if it was finished telling us everything. We'll only know that we stopped being able to hear it.